Mars was once alive, with rivers, lakes, and maybe even life. So what went wrong? Scientists have finally uncovered the real reason the red planet died. And it's more terrifying than we imagined. There's overwhelming evidence in favor of liquid water being present on Mars billions of years ago, and even some evidence that it still has some in an extremely limited capacity today in underground reservoirs and polar ice caps. But Mars today is dry and barren with an atmosphere too thin to even allow liquid water to exist on its surface. The obvious question raised here is then, what happened to Mars? If Earth managed to keep its water and remain habitable, then why didn't Mars? The usual answer you hear about this is Mars' magnetic field shut down, its atmosphere got stripped away, and that was that. But this is not the whole story. New evidence shows that the death of Mars may not have been a simple gradual decline. A new study suggests that Mars went through no less than 7 major drastic shifts in climate that fundamentally altered the environment of the planet. And a separate study also suggests that even if Mars had a dense atmosphere and magnetic field to this day, it was likely doomed to be a desert planet anyway. Essentially, new data suggests that Mars was destined to become a barren planet no matter what, and the short periods of habitability were the rare exceptions, not the rule. So, what's so different about Mars? Why is Earth's habitable environment kept stable over billions of years? Well, even if you give Mars a bunch of water in a dense atmosphere and even a magnetic field, it inevitably tends toward becoming a desert. And what does this mean for the habitability of other planets? Is Earth just really lucky, or is Mars just really unlucky? The first thing we need to talk about here is the carbon cycle on Earth. The carbon cycle is extremely important in keeping this planet habitable. A rise in carbon dioxide in the atmosphere leads to a rise in temperature. However, a rise in temperature increases the rate at which chemical reactions lock excess carbon dioxide into rocks, taking it out of the atmosphere. This keeps Earth's temperature relatively stable, though obviously there are still major fluctuations, and prevents the planet from experiencing a runaway greenhouse effect and turning into Venus. This same process will eventually cause the extinction of all life on Earth in about 1 billion years or so, when the increased temperature of the sun causes most carbon dioxide on Earth to be locked into rocks, stopping photosynthesis worldwide. I have another video about Earth in 1 billion years if you want to know more. But Mars' atmosphere is 96% carbon dioxide, and it, like Earth, has rocks. This means that a carbon cycle will take place on Mars as well. However, we haven't yet talked about the way carbon dioxide is released back into the atmosphere to complete the cycle. On Earth, this is achieved through volcanism. When volcanoes erupt, they release CO2 back into the atmosphere and warm the planet back up, creating a full carbon cycle. Our planet is so volcanically active because we have tectonic plates, creating all sorts of volcanic structures that are rarely seen anywhere else in the solar system. However, Mars has a stagnant lid. Instead of the crust being split into plates, the entire thing is one solid, unmoving structure. This is the reason Olympus Mons is the tallest volcano in the solar system. Instead of the crust moving around, the volcanic hotspot that created Olympus Mons just kept erupting in the exact same spot over and over until things got out of hand, and we got a volcano as wide as France, so tall it literally reaches into space. This also makes Mars significantly less volcanically active than Earth, causing its carbon cycle to be vastly different, even in the presence of liquid water, which can speed it up. In this case, Mars' carbon dioxide is pulled out of its atmosphere faster than it can be replaced, causing the temperature to drop and turning the planet into a cold desert. Because the sun naturally heats up by about 8% every billion years or so, Mars slowly gets warmer. However, as I said earlier, this increases the speed of the carbon cycle, causing it to turn back into a cold desert every time. So Mars' death wasn't caused entirely by the shutting down of its magnetic field, though that was a factor. Even assuming everything went perfectly for Mars and it retained a thick atmosphere warm enough for oceans, it seems that the entire planet self-regulates into becoming a barren wasteland every time. I've alluded to this in past videos, but this also suggests that plate tectonics may be an extremely important factor in planetary habitability. This problem won't be unique to Mars, and there would be thousands of exoplanets across the Milky Way that could have been habitable if it weren't for a lack of volcanic activity balancing out the carbon cycle. Also, Earth is the only planet in the solar system with tectonic plates. It may not be a coincidence that it's also the only planet that is still habitable after billions of years. Though, notice that I said still habitable after billions of years, not habitable in general. Plate tectonics seem like they may be important to the long-term habitability of a planet, but may not be a requirement for habitability in general. We know this because we know Mars had liquid water at some point. Also, before I get on to the potential 7 major climate shifts Mars may have experienced, I'd also like to mention its axial tilt. Mars' obliquity or axial tilt is unstable over time scales measured in tens of thousands of years and is sometimes as low as 0 degrees, meaning it has no seasons, and as high as 60 degrees, making the planet almost flip on its side like Uranus. This has extreme implications for the Martian environment as well, as more drastic seasonal changes lead to differences in where liquid water is even possible. For more information about this and how it can even lead to the entire Martian atmosphere to collapse, I have a video about this that will be linked in the description. This is important because Mars having liquid water does not mean it was Earth-like. Personally, it seems to me that Mars was an icy planet with equatorial lakes fed by ice-covered rivers, a scenario I covered in the video I just mentioned. Mars experiences extreme changes in climate depending on how high its axial tilt is. And that axial tilt varies on very fast timescales in planetary terms, with the difference of 0 degrees and 60 being separated by only a few 10,000 years. Though compared to the other climate changes Mars went through, the effects of the changes in obliquity are far less important. This is where the second study comes in. Though before I get into it, I'll just say that right now there's no true consensus on how the history of Mars unfolded. And this is only one recent theory of many. This study suggests that Mars did not undergo a single wet-to-dry transition, the popular theory you may have heard, but actually experienced 7 different shifts going from wet to dry again. And most interestingly, Mars may have been in its last wet period less than 3 billion years ago. Meaning, if this is true, Mars had intermittent habitable conditions for as long as 1 billion years. However, the planet also experienced long dry periods in between. So, if Mars did have these habitable conditions, they weren't stable habitable conditions. The oceans flooded and receded several times, and some places were completely dry in just a few 100 million years after Mars formed. This has some very interesting implications for any potential Martian life. I've said a few of my opinions about life existing on Mars in past videos, but they're worth repeating here. I think it's completely impossible that any kind of life more advanced than bacteria ever existed on Mars, because complex multicellular life on Earth took over 3 billion years to evolve, and Mars just simply wasn't habitable for that long. I don't rule out the possibility of microbial life having existed here. However, I think that if it does, it has a pretty high chance of being related to Earth life. This is because while we don't know how life first appeared on Earth, it seemed to have required volcanic activity in some capacity, something we know is very different on Mars. So, I'm hesitant to consider the idea that Mars could have formed life independently. And Mars and Earth are pretty close together, and we have meteors on Earth that came from Mars. So, it is more than possible that some meteor containing microbes was blasted off Earth and deposited into the Martian oceans. So to be clear, I think Mars developing life on its own is unlikely, though not impossible. But I think that complex multicellular life on Mars is completely impossible. And if we ever do find evidence of life on Mars, I wouldn't be surprised if it's a distant ancestor of Earth life. Though I'm not a biologist, and these are just my opinions based on the research I've seen, and I could be completely wrong. Anyways, if this idea of Mars going through cyclic wet and dry periods is true, then if this planet did have life, then it was likely hindered even more than it already was. I wouldn't be surprised if these transition periods acted sort of like mass extinction events, for example. And if a Martian ecosystem ever existed at all, it was probably far less expansive than Earth due to the reasons I've mentioned already, making these transitions even more devastating for anything that may have been living there. But that's enough talking about alien life. I tried to avoid alien speculation on my channel and focus on the actual science, but I thought it was worth talking about in this case, because I actually think it's pretty likely that Mars had life at some point or another. It's right next to a planet with a massive biosphere that's constantly hit with asteroids, and life containing fragments could have easily been spread across the solar system. But again, total speculation on my end. We have no evidence of life ever existing on Mars, or any evidence that interplanetary Panseria is a viable method of creating a biosphere on another planet. But no matter what, it seems that Mars is a very unstable planet, both on the short and long term. These cycles of wet and dry only stopped because eventually the atmosphere became too thin to support liquid water entirely. But there's nothing saying it can't be started up again. A lot of carbon dioxide is trapped in the Martian ice caps, and the sun is heating up at a faster and faster rate. Maybe as it begins expanding into a red giant, these cycles will begin again, and Mars will once again experience intermittent habitability. And more interestingly, in my opinion, this instability just isn't present on Earth. We have a large moon that stabilizes our axial tilt over long time scales and volcanic activity powerful enough to release carbon dioxide back into the atmosphere as fast as it's taken out, allowing Earth's environment to be relatively stable over billion-year time scales. It seems there's a lot that goes into planetary habitability. Having the right temperatures just isn't enough. And this is one of the reasons I expect habitable planets to be rare in the Milky Way. However, I think there's now a pretty important distinction to make. Planets that are habitable may be uncommon, but it seems that planets that are habitable and stay habitable are going to be even rarer. I think it's pretty likely that stable, long periods of habitability are necessary for intelligent life to evolve. And so, this could even be one part of the solution to the Fermi paradox. Really, this topic deserves its own video. So, I'll stop here as this video is about the death of Mars. It seemed that this planet was destined to become a barren desert no matter what happened to it. And only time will tell if this is an exception or a rule for habitable planets across the universe. Hit that subscribe button, share your thoughts below, and let's keep exploring the together. Thanks for watching, and we'll see you in the next.